Hello guys, good evening. How are you doing? Let me switch on another light. Yes, okay, here we go. People are coming in. Am I clearly visible or shall I illuminate the room even more? Hello people. Visible? Cool. Let me just get my laptop a little up. Visible, visible, visible. Okay. Now this is okay. In Lucknow, it is chilling, guys. It's like daily below 10-degree temperature, even during the day. So it's totally chilling here. So are you in Hyderabad? No, no, no. I'm not in Hyderabad. I'm at home, at my home, Lucknow. Good evening. Good evening. Good evening. I'll wait for 2 more minutes. सर कैसे हो? बहुत बढ़िया, पर बहुत ठंड है. Internet services resumed in Lucknow. No, internet services are still not running, but broadband is fine. Broadband is going on smoothly. Mobile internet services are not active. Dinner is not done yet. आपका book collection अच्छा है. Oh, this is only limited collection. Bigger collection is in my what do you say, wardrobe. मशीन डिजाइन की क्लास का टाइमिंग क्या होगा? फॉर मशीन डिजाइन एसी चलाओ. अच्छा बेटा. कितनी देर तक चलेगा सर क्लास? 1 hour. बिकॉज आई एम ऑलरेडी वेरी हंग्री. आई हैव टेकन वन क्लास फॉर ESE students. Sir is famous for poetry and machine design. Yes, your book for GATE is very good and very helpful. MD 30 questions class is tomorrow on YouTube 3 to 6. पीछे तो देखो, पीछे तो देखो. I'm looking so tired. Yes, I'm looking tired because today has been very busy day for me, and partially I'm looking tired because of this low lighting. If I'll increase the lighting, now it must be okay. No, it's your home. Yes, it's my home. Your book Gate in 75 days is useful now. It is useful, but don't try covering all the subjects from that book. Now it is better to focus on 3-4 subjects. So for 3-4 subjects, it will be very good for complete revision. For 3-4 subjects, you can quickly complete them. Because one subject is roughly going to have 7 days. So 3 4 subjects means 28 days. So in 1 month you can complete 4 subjects. भूला नहीं वो बारिश जो तूने दी थी. Is still your favorite? Okay, so people have joined in. People are still joining in, but we'll start. We'll start velocity and acceleration. Guys, I'm not going to tell you, the theory of the world. वो बात और होती है आंगन जो मेरा होता. Okay, people are completing it. Namaste, Hussain ji, namaste. Will acceleration diagram start today? Uh, Bhagavad Gita is there. Yes, Bhagavad Gita is there at the top. Actually, that's the only religious spiritual book that I have believed in. I mean, that's at the core of my life philosophy that has inspired me a lot. Hydro, welcome, welcome. Where should we concentrate in camps chapter, sir? We will discuss regarding camps. I'll try to do a YouTube session. Okay, guys, let us not waste the time and let us start this. Please take camps. Some doubt in slope and deflection. Swapnil, are you the same Swapnil? Swapnil? Okay. CS की story बाकी है. हाँ. Why not? Okay, Swapnil. If I'm not wrong, it's about, you know what I'm talking about. Okay. Is rolling without slipping covered in this session? No, in this session, we will try to cover only constraint mechanisms. Though rolling without slipping can also be done through constraint mechanisms, but we will see. If the need will arise, we will conduct more special classes, don't worry. I will complete entire velocity and acceleration. If not in these 2 classes, I'll conduct one more special class. Okay, acceleration diagram I'll cover, don't worry. So guys, let's go ahead and start. My humble request, Swapnil, you can call me. You can call me regarding the doubts. Okay. Mechanics का special class लीजिए. I'll try. Actually, I have very limited special classes available on this Unacademy platform. Really nice of you. You're any day welcome, dear. You're any day welcome. Please do start the session. Sure, Hussein. We will start the session because gate is very near. So yes, we should not waste the time. So we are now going to discuss about velocity and acceleration in mechanisms. Velocity and acceleration in mechanisms, in constraint mechanisms, which is not a part of mechanics, which is a part of Tom, which is a part of Tom. आशुतोष is asking complete courses कब से start होंगे गेट 2021 के लिए. आशुतोष, if you are already subscribed, let me tell you that regular courses will start in February. February first week, I'll start the regular courses. And if you are not subscribed, then while subscribing, don't forget to use my code MTLive. You see, promotion भी कर दूं थोड़ा सा मैं. Anyways, समझो अभी. Please be very attentive and try understanding velocity and acceleration in mechanisms. Guys, in constraint mechanisms, there is always some constraint available. And my approach has been, again, every single approach requires a little practice. After you have, बहुत ध्यान से समझियो. After you have, now one humble request, please stop, commenting in the chat box, and for 45 minutes, please stay very attentive. बहुत ध्यान से समझियो. Velocity and acceleration. In constraint mechanisms, there is always some constraint available. And if you can guess that constraint, then you can get the displacement equations, and then you can get the velocity equation and acceleration equation very quickly. For example, I'll take some examples here. For example, you think about slider crank chain. You think about slider crank chain. In case of slider crank chain, you have a fixed center here. You have a fixed center here and you have a slider here. You have a slider here, and let me call this point as O, and let me call this point here, this connection here as A, and let me call this connection here as C. Let me call this connection here as C. Now let us say, please be very attentive and try understanding, because the approach that I'm going to tell you is a little new. I mean, new in the sense that you may not have learned about it, and it will require a little practice, but it's a no-brainer approach. No-brainer means once you write the very first equation, then it is a mathematics thing. You need to differentiate, differentiate, differentiate. That's it. So please be very attentive and try understanding. Suppose this connecting rod has the angle phi. Suppose this connecting rod has the angle phi. And suppose this crank has got the angle. Suppose this crank has got the angle. So please be very attentive and try understanding. Huh? Crank has got the angle theta. Suppose the connecting rod has got the angle phi and crank has got the angle theta. Okay. And the position of the piston at any given instant is x. Position of the piston at any given instant is x. Now suppose the length of the connecting rod is L and the length of the crank is R. The length of the crank is R. Can you relate X and L and R? It's very easy. Think about it. It's very easy. My dear friends, if you drop a perpendicular here, then it's very clear that it's very clear. Please be very attentive and try understanding that this is L cos phi. This is L cos phi, and this one is R cos 180 minus theta. This red one is L cos phi, and this blue one is R cos 180 minus theta. And this entire thing is what? This entire thing is X. X is what? X is the position of the slider at any given instant. At any given instant. Okay. This method is so beautiful that you don't have to learn a lot of theory. You can just begin right away. Up start हो जाओ. कोई भी theory नहीं पढ़ना है. कोई 10 concept नहीं पढ़ने हैं. आप सीधे सीधे start हो सकते हो. You can start right away. You can very clearly see that this red one is L cos phi and this blue one is R cos theta. And my dear friends, this L cos phi and R cos theta is nothing but X. So you can write X is equal to L cos phi and plus R cos theta. Why we have not taken crank angle outside? R cos 180 minus theta. That's thanks for correcting me. R cos 180 minus theta. Sir, it's a usual practice to represent all the angles from any one given direction. Like if you're choosing positive x, then measure all the angles from positive x. Just follow this. Okay. So those who have joined late, let me tell you clearly once again that I'm not going to discuss about any diagram approach and all. I'm not going to discuss about any diagram approach and all. I'm going to tell you velocity and acceleration through a very fantastic method. And that fantastic method is called as, that fantastic method is known by the name, that fantastic method is known by the name constraint equations. So those who have joined late, please join the class as early as possible and try understanding what we are doing here is that there is this slider and there is this crank and there is this connecting rod. I assume the angle of the connecting rod is phi, and I assume the angle of the crank at any given instant as theta, and the length of the connecting rod is L, the length of the crank is R, and this point here is the connection between the connecting rod and crank. And let's say the position of the slider at any given instant is X. Now listen, I'm saying it once again. Listen, I'm saying it once again that this is what? This length is what? This length is L cos phi. Drop a perpendicular here. Then this length is, this red one is L cos phi. Okay. This one is L cos phi. And what about this blue one? What about this blue one? This blue one is R cos 1 minus 180 minus theta. R cos 180 minus theta. But total is what? Total is equal to X. So you can simply write X is equal to L cos phi plus R cos 180 minus theta. Isn't it? L is a constant, R is a constant, but theta, phi, and x, they are the variables. Theta, phi, and x, they are the variables, but x and L and R, they are constants. They are constants, okay? And there is one more equation that you can write. Once again, look at this triangle and tell me, once again, look at this triangle and tell me what is this vertical distance. This slider crank mechanism, what is this vertical distance? This vertical distance is L sine phi. But wait, this vertical distance can also be written as R sine 180 minus theta. R sine 180 minus theta, isn't it? So this vertical distance can be written in two ways. This vertical distance can be written in two ways. L, this vertical distance can be written in two ways. One is L sine phi, another is R sine 180 minus theta. I like this approach because in this approach, we don't have to take any component, we don't have to take any diagram, we don't have to sketch anything. Just write these equations and differentiate them. If you differentiate them, you'll get velocity. And once you get the velocity equation, differentiate again, you'll get the acceleration. These equations, my dear friends, are known by the name constraint equations. These equations are known by the name constraint equations, but please don't try to use these equations in mechanics when a free body is moving, because these equations will be available only in tome problems where you have a constraint mechanism. Okay, so let me try solving a problem and you will understand. You will understand how this works. I just gave you one example. I just gave you one example. Let me very quickly try solving a problem and you will understand. Okay. Sir, what is a constraint mechanism? Look, Yashwant, constraint mechanism is the mechanism that is having 1 degree of freedom. I'm glad you asked I'm glad you asked. Constraint mechanism is completely constrained mechanism is a mechanism with degree of freedom 1. What is the implication of this? The implication of this is, look, here you have three displacements. How many displacements? Three displacements. Here you have three displacements. One is the one is the linear displacement of piston. One is the linear displacement of piston. Another is the angular displacement of connecting rod. And third one is the angular displacement of the crank. But you have three displacements. One is the linear displacement of piston, and then angular displacement of connecting rod, and then angular displacement of crank. तीन हो गए नहीं, लेकिन तीन तीन चीजों को अगर दो इक्वेशंस से रिलेट कर सकते हो तो इंडिपेंडेंट कितने बचे? If three unknowns can be related with two equations, then how many independent parameters are left? Only one independent parameter is left. That means if you know x, then you can calculate theta and phi. If you know x, you see, if you know x, if the x is known, then phi and theta and phi and theta. Two equations, two unknowns. Two equations, two unknowns. This is what we call, one is the correct answer. I asked independent displacements. Independent displacements are one only. Okay. So let me solve a problem and you will understand. Okay. Let me solve a problem. Here we go. This is the problem. This is the problem that we have. As a very first problem, we'll try solving this. Is that visible or shall I make another diagram? That must be visible. Okay. Visible, 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 cool, cool. Okay, listen and try understanding. Listen and try understanding. Guys, you have this slider. You have this slider and you have the connecting rod and you have the slider and connecting rod and crank. And I told you that this is the X position of the slider and this phi is representing the angle of the connecting rod and this theta is representing the angle of the crank, and the length of the connecting rod is given as 200. Length of the connecting rod is given as 200 and length of the crank is given as 130.55. Okay, if the crank is rotating at 10 radian per second, we need to calculate velocity of slider and we need to calculate angular velocity of connecting rod. Now, if you want, you can do it. I mean, there are so many methods available. There are so many methods available, believe me. But as I said, I always prefer constraint equations. What are the constraint equations? Focus yourself here and try understanding. Please focus yourself here and try understanding. Guys, this vertical distance AD can be written as L sine phi. This vertical distance AD can be written as L sine phi, and this vertical distance AD can also be written as R sine 180 minus theta. But you know, sine 180 minus theta is nothing but sine theta. So you will get sine phi is equal to R divided by L sine theta. you will get sine phi is equal to r divided by L sine theta. This vertical height AD can be written as L sine phi. Looking at this triangle, it can be written as L sine phi. And looking at this triangle, जिसमें मैं point बना रहा हूँ, it can be written as r sine 180 minus theta. r sine 180 minus theta. इस तरह की इक्वेशन को कहते हैं constraint equation. Such an equation is known by the name constraint equation. Okay. Now you differentiate this. You differentiate this quickly. If you differentiate this, sine phi differentiation will become cos phi. And then differentiation of phi is nothing but the angular velocity of connecting rod. On the right hand side, you have differentiation of sine theta will become cos theta, and theta derivative is nothing but angular velocity of crank. Okay, so you'll get all the values are known to you. You are interested in angular velocity of connecting rod. You are interested in rate of change of the angle of the connecting rod. Remember, phi is for connecting rod. Okay, so phi is for connecting rod. So derivative of phi will represent angular velocity of connecting rod. So this will become cos theta divided by cos phi, and r by L and theta dot. You get very easily everything. Theta is what? Theta is, believe me, theta is 130 degrees. I'm proving it. Believe me, as of now, theta is 130 degrees in this figure. And phi is what? Look here, here. This. Phi is 30 degrees. Please don't put the values before differentiating, okay? Put the values only after differentiating. And R is what? R is 130.55. And L is what? L is length of the connecting rod is 200. What is the angular velocity of the crank? It's given as 10 radian per second. Angular velocity of the crank is given as 10 radian per second. Calculate the angular velocity of connecting rod, please. Please calculate the angular velocity of connecting rod. Guys, please calculate the angular velocity of connecting rod. So whenever in a slider crank chain, they give you the angular velocity of crank and they ask the angular velocity of connecting rod, just do this and you'll get the answer in one line. 7.542. 7.42. I don't think so. Cos 130 divided by cos 30 into 130.55 divided by 200 and into minus 10. Minus 10. Yes, all of you are correct. Perfect. This is minus 10. I'll tell you why minus 10, don't worry. I will tell you why minus 10. You don't worry about it. So if you put this as minus 10, then you will get phi dot positive 4.84 radian per second. This is the answer. This is the answer of this part. Cool. This is the answer of this part. Let me just enclose it. Now, one thing I have not explained so far, that is that theta is 130 degrees. Why it is 130 degrees, I will tell. Angle theta, I'll explain. But first of all, let me write another constraint equation. What is another constraint equation? Another constraint equation is, look, another constraint equation is L cos phi plus R sine 180 minus theta, L cos phi plus R cos 180 minus theta is equal to X. How sine theta became, I differentiated sine, so it became cos, then again the differentiation of phi. Similarly, differentiation of sine has become cos, and then again the differentiation of theta. Perfect. Okay. शुरू में थोड़ा ऑड लगेगा आपको क्योंकि आपने कंस्ट्रेंट इक्वेशंस शायद पहले कभी नहीं सीखी हैं. Maybe you have not learned ES chain rule. So it will be a little odd in the beginning, but once you understand all this, you'll be easily cracking them. Okay, now listen. Now listen. Now listen. Now listen. L cos phi plus R cos 180 minus theta is nothing but X, the position of slider. Okay, the position of slider. So I can write another constraint equation that X is equal to L cos phi plus R cos 180 minus theta. I hope you understand this. Now you can further write X is equal to L cos phi, and cos 180 minus theta is minus cos theta. Cos 180 minus theta is minus cos theta. So now we can write, if we differentiate now, look, I'm differentiating, okay? I'm differentiating. So now I can differentiate this, and if I differentiate, I'll get, what is the differentiation of cos phi? Differentiation of cos phi is sine phi. And then again, what will be the derivative of phi? It will be phi dot. Basically, the derivative of angle is nothing but angular velocity. And then the derivative of cos theta will become, sine theta, and the derivative of theta again will become theta dot. Now listen, everything is known to you. Every single thing is known to you. बताना सर कैसा रहा? Is this better that I'm doing, or velocity diagram and acceleration diagram and all those things are better? I don't know. L is, this is good actually. L is 200, phi is 30 degree. Look here. In the given figure, phi is given. In the given figure, phi is given as 30 degree. and phi dot we have obtained as 4.84, and R is given as 130.55. R is 130.55 and theta is 130 degrees. Theta is 130 degrees. And what is the angular velocity of the crank? Angular velocity of the crank is minus 10. Now, one thing that will confuse you immediately, I know, one thing that will confuse you immediately is why I'm putting theta as minus 10. I will tell you. First of all, you solve this. First of all, you solve this and tell me what exactly are you getting. Minus 1484. Ah, minus 1.48. That's perfect. I'm a student from Delhi Center. Great. Delhi people have always been very close to me. Okay, so is theta given in the question? Phi is given in the question. How theta I have calculated, I'll tell you. Don't worry. Otherwise, phi is given in the question. Look here. Look here. Phi is given, okay? You're getting minus 1.48. Same answer got by I center. हाँ, जो सोम बाबा बोलेगा वो मैं समझ जाता हूँ, दिल्ली से ही है. तो ये क्या मिला सर? ये मिला minus 1.48 मीटर पर सेकेंड. अब देखो, एक बात, टॉम क्रूज, minus 1.48 मीटर पर सेकेंड. दिस इज परफेक्ट. नाउ लिसन, इस मेथड को फॉलो करते समय आपको एक दो बातें ध्यान में रखनी होंगी. When you are following this constraint equation thing, then you'll have to be very careful about one or two things. Two things rather. Listen, guys, if you're attending the session from very beginning, L cos theta plus R cos 180 minus theta, explain once. Okay, I'll explain. Sushant, I'll explain in the next slide. Theta is taken in negative, but phi dot answer is positive because cos 130 is negative, no? Because cos 130 is negative. I'm telling everything. First of all, you look at the solution. All of you look at the solution. Only single crank mechanisms. आपका book gate in 75 days is helpful. Thank you so very much. ये ऑफलाइन अवेलेबल रहेगा ना? हाँ जी, अवेलेबल रहेगा. बार बार देखो, 1000 बार देखो. देखने की चीज है हमारी स्पेशल क्लास. Oh, you're preparing from that book? Great. Now listen. Now listen. There are few things that you must keep in mind. Number one, that try this method only suitable for single slider mechanism. Balaji, patience. I tell you the method that is going to be applicable in all possible mechanisms of the world. Okay? In your syllabus, only 1 degree of freedom is there. So for 1 degree freedom, this method is cool. Now listen. In super question 6, we had used the same trick. Yes. Now listen, all of you. That this method is better. Why? Because this method doesn't ask you to draw any diagram. All right, no velocity diagram, no acceleration diagram, nothing. That's why I अनअकैडमी प्लस लेना जरूरी है क्या? हाँ जी, लेकिन अनअकैडमी प्लस लेने से पहले मुझे कॉल जरूर कर लेना. आई विल मेक सम फर्दर डिस्काउंट अवेलेबल फॉर यू. Just in case if somebody is planning for an Academy Plus subscription, please make sure that you call me before taking the subscription, because few students have taken the subscription without consulting me. Hello Abhijit, welcome to the class. Now listen, all of you, stop chatting, stop chatting, and focus yourself here and try understanding. When you are using constraint equations, then you'll have to keep two things in your mind. Number one, the angle you should measure, the angle you should measure from any one given, maybe positive x, maybe negative x. It is up to you. But please make sure that angle you measure only from one given direction. Maybe positive x, maybe negative x. But please measure the angle only from one given direction. That's why you look, I have measured phi and I have measured theta both from positive x. सबसे पहली बात, the very first thing. Now the second thing. Now the second thing. If your actual angular velocity happens to be opposite to the theta, if your actual angular velocity happens to be opposite to the theta, then put it negative. Then put it negative. These two things you must remember. Okay? These two things you must remember. We solved this problem by using the constraint equation. Now Susant asked that please explain it once, that how I have written. Susant asked that please explain it once as to how I wrote this x is equal to L cos phi and R cos 180 minus theta. This is very easy to understand. This is very easy to understand. Don't worry. Theta is minus 10 degree. No, it is not minus 10. Listen, listen. You guys listen first. Then you will understand. This is why. Now, Sushant and all other people out there, you tell me, what is this distance? If you drop a perpendicular here, what is this distance, this horizontal distance? This horizontal distance is very clearly L cos phi. And what is this horizontal distance? What is this horizontal distance? This horizontal distance is very clearly R cos this angle. This angle is what? This angle is 180 minus theta. Isn't it? 180 minus theta. So now I can write x is equal to, L cos phi plus R cos 180 minus theta. Simple. And then I differentiated, x dot is equal to L, and differentiation of cos phi became sin phi, and phi dot differentiation cos 180 minus theta is, okay, I've done it. I've done it already. All these things. I say it once again. Please do remember two important things. Number one, that all the angles you will measure from positive x-axis only. Number one, that all the angles you will measure from positive x-axis only. Number two, that if your given angular velocity is opposite to the sense of the angle, if your given angular velocity is opposite to the sense of the angle, then that angular velocity you will put negative. That angular velocity you will put negative. Okay? That angular velocity you will put negative. Got it? Cool. Theta 30, I'm 130, I'm coming to that. Why theta is 130 degrees? I'm coming to that. Look, you have you have this angle given as 30 degree. This is 200 and this is 130.55. This is 130.55. Let's say this is alpha. Then apply the sine rule. What is the sine rule? That 200 divided by sine alpha is equal to 130.55 divided by sine 30 degrees. Okay, calculate alpha quickly. Somebody please calculate alpha quickly. Swami is saying mechanical engineering class. Swami, yes, it is mechanical engineering class. Did you happen to be in wrong class? इसमें भी शक है कहाँ? Now alpha is 50 degrees. So what will be this angle? You tell me. If alpha is 50 degrees, what will be theta? Very simple. Now you understand. Theta will be 180 minus 50, which is nothing but 130. Perfect. Now, कुछ और भी प्रॉब्लम्स देखते हैं सर, तब तो मजा आएगा ना. Balaji, you said that is this valid only for single slider crank chain? So the answer is no. Here you have a double slider crank chain. Here you have a double slider crank chain and velocity of slider A is given. Look guys, try understanding the question at the very first of all. As a second question, I'm taking this that we have velocity of the slider A is given here and we have to calculate velocity of slider B. Okay. And we also have to calculate the angular velocity of this rod AB. We also have to calculate the angular velocity of this rod AB. Okay. Crank and slotted, I'll take tomorrow. Crank and slotted, I'll take tomorrow. Okay. And if the need will arise, I'll take one more special class. Just like in vibrations, we have taken 3 special classes. In this topic also, I'll have one more special class. Don't worry. If the need will arise, I'll take. आपका contact number change हो गया क्या? No, no, no. My contact number is same. I'll give. Don't worry. Let me complete the problem first, guys. You see, the problems are more important than. Okay, here is a humble request. Please don't write anything in the chat box for further 10 minutes. Just 10 minutes, huh? Because you are learning a new method, a newer approach for velocity and acceleration. So that's why I'm taking a little bit of time. Now listen and try understanding. Here we have a double slider crank mechanism. In this double slider crank mechanism, slider A is moving with 1.5 meter per second. Then at this given instant, when the rod is making an angle of 60 degrees, then what will be the velocity of slider B, number one, and number two, what will be the omega. So you can solve it in so many ways. You can solve it in velocity method, you can solve it in eye center, you can solve it relative velocity diagram. But I'm going to use a constraint equation. This point A is moving to the right side 1.5 meter per second. So let's say the position of this point A with respect to a fixed point at any given instant. Let's say the position of this point is x. And as this point A will move to the left, as this point A will move to the left, point B will move to the downside, isn't it? As this point A will move to the left side, just like a ladder slipping on the floor. जैसे एक सीढ़ी अगर फ्लोर पे टिकी हुई है और ऐसे खिसक जाए, तो ये टॉप वाला पॉइंट किधर जाएगा? ये टॉप वाला पॉइंट, ये टॉप वाला पॉइंट यहाँ पर ऐसे नीचे आएगा, ऐसे नीचे आएगा। इसकी पोजीशन मान लेता हूं मैं। Let me assume the position of this topmost point. If A is moving to the right side, then B will move down. B will move down, not right. You see, it's a constraint thing like this. Double slider. Okay, so point B will come down. Let's say at one given position, at one given instant, the position of B is Y. And let's say that the angle of this rod is, let's say that the angle of this rod is theta. Okay, now you tell me, you have to find out two things, by the way. You have to find out two things. You have to find out the velocity of slider B, and you have to find out the angular velocity of the connecting rod. You have to find out the angular velocity of the connecting rod. So can you relate x and theta and L? It's very easy. Because why x? Because x velocity is given. So I'm that's why I'm focusing on x. Can you relate this x and this 180 minus theta and L? That's very easy. That's going to be x divided by L is equal to cos 180 minus theta. And cos 180 minus theta is nothing but cos 180 minus theta is nothing but minus cos theta. Now this is constraint equation. Why? Because I'm relating two positions, two displacements here. One is the displacement of the slider, another is the angular displacement of the connecting rod. One is the linear displacement of the slider, another is the angular displacement of the connecting rod. इसे कहते हैं hip hop. I mean constraint equation. This is what you call constraint equation. Now you differentiate this quickly. You differentiate this, and if you differentiate this, you will get, after differentiating this, you will get derivative of x, and here you'll get derivative of cos theta will become sine theta, and then derivative of theta again will become theta dot. Now, what is x dot? X dot is nothing but velocity of slider A. X dot is nothing but velocity of slider A. X dot is nothing but velocity of slider A, and this is given to you 1.5. Theta is nothing but 180 minus 60. Theta is nothing but 180 minus 60. 180 minus 60. Calculate theta dot from here because length is given. Length is given 0.625. Calculate theta dot from here. That will give you the angular velocity in one line. That will give you the angular velocity of the rod in one line. Perfect. You get 2.77. You get 1.5 divided by 0.625. Further divided by sine 120. 2.77 radian per second. 2.77 radian per second. Now, what about the other one? What about the other one? For the other one, you try bringing y into the picture. To get the velocity of slider B, you try relating y either with theta or with x. It's up to you. Now both are known. पहले क्या known था? देखो, पहले क्या known? अभी बताता हूँ डायरेक्शन. रघु, listen. अभी बताता हूँ डायरेक्शन. डायरेक्शन यही है. आपका एंगुलर वेलोसिटी पॉजिटिव आया ना? पॉजिटिव आया तो मतलब जो थीटा आपने अज्यूम किया था वो परफेक्ट है. आपका एंगुलर वेलोसिटी पॉजिटिव आया, आपने जिस सेंस में थीटा अज्यूम किया था वही एंगुलर वेलोसिटी का सेंस होगा. ओके, दिस इज एंटी क्लॉकवाइज because we assumed anti-clockwise theta. So this is anti-clockwise. होना भी चाहिए, ऐसे देखो ना, ऐसे नीचे जा रहे हो. एनीवेज, देखो सर, इसमें थोड़ा सा आपको केयरफुल रहना पड़ेगा. मैंने शुरू में y और थीटा को नहीं रिलेट किया. मैं चाहता तो y और थीटा को रिलेट कर सकता था, लेकिन मैंने देखा कि मुझे x वेलोसिटी गिवन है, तो मैंने x और थीटा को रिलेट किया. I saw that x velocity is given, so I related x and theta together. I did not relate y and theta. Now theta is also known. I mean, theta derivative is also known, and x derivative is also known. So it is up to you. You can relate y with anyone. It is totally up to you. It is totally up to you. So, which one will you prefer? Well, I think I am going to prefer. I think that in the second part of the solution, I'm going to prefer with x and y. I mean, okay, I know you're going to prefer my method, but in my method also you have two choices available here. One is you can try relating y with x also, you can try relating y with theta also. And why both are going to work? Because we have theta angular velocity also known now. So both will work, but I'll relate y with x. X square plus y square is equal to L square. Differentiate this. If you differentiate this, you get 2x. And what is the derivative of x? Derivative of x is x dot. If you differentiate y square, you will get 2y. And what is the derivative of y? Derivative of y is y dot. And what is the derivative of L square? Derivative of L square is 0. Now, दो ने दो को मार दिया. दो ने दो को मार दिया. What is left? X dot plus y dot is equal to 0. Then you will have y dot is equal to minus x divided by y minus x divided by y and x dot. What is x dot? X dot is the velocity of A. X dot is the velocity of A. And this is known to you already. 1.5. What is x and y, guys? X is, at given instant, x is 625 cos theta. X is 625 cos 60. And y is 625 sine 60. Can you please and please? Very funny and interesting method. Yes, it is. Yes, it is. Constraint equations are always, at least for 4 link mechanisms, it is one of the best methods. So y dot is, you get y dot, calculate y dot. Y dot means velocity of slider B. Y dot means velocity of slider B. This will become 625 will get cancelled. Sine 60 divided by cos 60 into 1.5. I'm getting 2.59. पवन सर को आप छोटा कर दिए। अरे सर, कहाँ पवन सर, कहाँ मैं उनसे बहुत छोटा हूँ। मैं उनसे बहुत छोटा हूँ। आई एम ऑलवेज लर्निंग फ्रॉम पीपल, आई एम ऑलवेज लर्निंग फ्रॉम, हाँ वो बाहुबली हैं एक्चुअली। पवन सर is a person whom I have respected always and I've respected very much. But अब जहां तक मैकेनिकल इंजीनियरिंग का सवाल है, तो मैकेनिकल इंजीनियरिंग में तो सर it's cot theta. X is, yes, cos 60 is in denominator, numerator, and sine 60 in denominator into 1.5, 0.866. Perfect. 0.866 यो। मेरा मन तो अभी है और पढ़ाने का, बट मेरा पेट जवाब दे रहा है। कल करेंगे कुछ मैकेनिज्म के एक्सीलरेशन इसी तरह से। सर, अगर आप एंजॉय कर रहे हो, देन पढ़ाने का मन तो बहुत है, लेकिन सर बहुत तेज भूख लगी है। मैं लूंगा एक दिन और। You took y is equal to L sin theta, got the same answer. Perfect. Number दे दीजिए. My number is already there with you. Tell me about plus subscription. Sameer, please call me. I'll share about the plus subscription. Just one humble request to you guys, that please recommend your juniors to come in my शरण। मेरी शरण में आने को बोलो। मैं बहुत अच्छे से प्रिपेयर कराऊंगा। मैकेनिक्स, सोम, टॉम, एमडी और एफएम। और आप में से भी जो लोग गेट 2021 के लिए प्रिपेयर कर रहे हो, ऑफलाइन क्लास तो नहीं छोड़ते थे जल्दी। ऑफलाइन क्लास नेवर रैन अप टू व्हाट डू यू से 10-15। Explain torque in a practical way. यशवंत, you call me, I'll explain, हाँ। नॉनवेज खाओ, एनर्जी आएगी। I don't know. I think in veg there are enough options to get the energy. बाकी एनर्जी तो मेंटल होती है। इसी शिवम सर डजंट हैव एनी फिजिकल एनर्जी, बट उनका मेंटल एनर्जी लेवल आपने चेक किया है कभी? आपका बस चले तो आप ले सकते हो, दैट्स ट्रू। दर्शन, आई एग्री विद यू, बिकॉज आई एम इन कंस्ट्रेंट मैकेनिज्म। You understand? So my displacement is related with thermal Baba. Yes. गेट 2020 के लिए कुछ बताइए। यू कॉल मी मणिकांत, यू कॉल मी, आई विल डिस्कस। Rajiv sir is there in Unacademy. We both decided to be a little adventurous. Jao and enjoy dinner. Sure. Uh, cool. I taught MD. That means you are belonging to PM batch. but you cleared some doubts also. Great. Metal forming का भी special class है आज. I am not aware about it. Important topics that we are not supposed to leave at any cost. Video. Sure. I'll make a video for this. Certainly, I'll make a video for this. Thank you very much for joining. Please like the class, and also whosoever is preparing for GATE 2021, or even if your juniors are preparing for GATE 2021 or your friends are preparing for GATE 2021, उनको बोलो मेरे शरण में आने को, क्योंकि मैं मैकेनिक्स सॉम टॉम एमडी एंड एफएम बहुत अच्छे से रगड़ के करवाने वाला हूँ. एंड कुलकर्णी सर इज ऑलवेज देयर फॉर थर्मल हेयर ऑन अन अकेडमी. Okay, so see you guys tomorrow again. Thank you very much for joining me. See you tomorrow. Okay, sure, Yashwant, I'll try. कल MD class का timing है. MD class happens. Sushant, MD class I'm taking only on ESE platform. MD class I'm taking only on ESE platform. On GATE platform, I'll start taking MD class in January. Please tell me mechanics in easy way. अभी इतना लिमिटेड टाइम में मैं क्या क्या सिखा दूं. Please, it's a humble request. Yes, Yeswant, I'll certainly make video. Okay, now you can call me. You guys have my number. So let me have my dinner. I'm very hungry. Extremely hungry I am. Hmm? Cool. Like the class before leaving, huh? हाँ कल 3 to 6 है. Okay. Sushant, you have been asking for MD class on YouTube. Tomorrow it is on 3 to 6, where I'm going to discuss entire machine design questions. Tomorrow 3 to 6 p.m. Afternoon 3 to 6. हाँ एक्सेलरेशन एनालिसिस विदाउट डायग्राम ही सॉल्व करूंगा यूजिंग दिस ट्रिक. कैन यू ज्वाइन अस फॉर डिनर? श्योर, कम ओवर टू लखनऊ. ओके गाइस, बाय बाय. प्लीज लाइक द क्लास, huh? Don't forget liking the class, otherwise I'm going to deduct your internal marks, I'm telling you. YouTube channel name for tomorrow: Unacademy Studios Bridge. Unacademy Studios Bridge. Pratyush, why are you creating this rumor that पिट जाओगे मत जाना यूपी को? It's a Lucknow is a very hosting place, and I'm going to host you. Whenever you visit, do give me a call. Okay, bye bye. Cool. Chalo sir. Thank you. Thank you so very much. See you tomorrow. Bye. I'm ending the class, huh?